Welcome to Click Academic. This is lesson 8 on the series Differential and Integral Calculus. We'll be discussing differentiation from first principle in this lesson. So my differentiation now, why are we harping on this? Is because for each successive example there's a different way to do it. So we've seen for algebraic functions now. So let's look at trigonometric functions. So we'll do cos x to see how it works. The sin x is pretty much the same way. At least very similar. So if f of x is cos x, then my f of x plus delta x is what? It's going to be, we said, replace x with x plus delta x. Quite straightforward. So using this now, we know our formula by now. My dy dx is just limit as delta x tends to 0 of f of x plus delta x, which is cos x plus delta x, minus f of x cos x divided by delta x. So dy dx is equals to the limits of this. So I'm going to use an identity for this to simplify this. We have an identity that says cos x minus cos y. That's two cos's multiplying and subtracting from each other. So we'll see that it says it's going to be 2 minus 2 sine x plus delta x plus x. It means x plus y divided by 2 times sine x plus delta x minus x divided by 2. Meaning the first plus the second divided by 2 and the first minus the second divided by 2 for the signs. So divided by delta x. This is an identity. So now we try and simplify this. This is limit as delta x tends to 0 of minus 2 sine x plus delta x. We see x plus x. This is just 2x plus delta x divided by 2 into sine x minus x is 0. So this is just delta x divided by 2. And we now have divided by delta x. So I'm going to do something here now. I'm going to take my minus 2. Since the relationship between minus 2 and sine, all the signs is multiplication, I can put it anywhere. I can put it in the middle or at the end. So I'm going to take it out totally, and I'll take this delta x out also. So this is going to be minus sine 2x plus delta x divided by 2 into sine delta x divided by 2 multiplied by minus my 2. I just took the 2, the minus is still there. 2 divided by delta x. So limit as delta x tends to 0 of minus sine 2x plus delta x divided by 2 sine delta x divided by 2. If I change this multiplication to divide, it will be divided by delta x divided by 2. So I can rewrite this as limit as delta x tends to 0 of minus sine 2x plus delta x divided by 2 sine delta x divided by 2 divided by this delta x divided by 2. Why did I do this now? So we've seen algebraic properties of limits already. We've seen that it says if I'm taking the limit of two things that are multiplying each other, I can take the limits of them each one separately. So we have a rule, a limit rule. It says limit as, for instance, theta tends to 0 if theta tends to 0 of sine theta divided by theta, and you can see theta tends to 0. This is just equals to 1. This is will I call it an identity? Okay, this is a fact, a given fact. So what we'll do is we'll use this rule to simplify this term. You can see that this is delta x tends to 0 of delta x divided by delta x divided by 2, and all divided by delta x divided by 2. So we'll just use this rule to simplify this. So we can see already that this is going to be 1. So I'll continue. This says limit. So my dy dx is equals to limit as delta x tends to 0 of minus sine 2x plus delta x divided by 2 times, using this law now, this is now 1. Sorry about that. This is 1. So to simplify this now, what do I do? This is going to be limit as delta x tends to 0 of minus sine 2x plus delta x divided by 2. So I can take my limit now. This is just minus sine 2x plus 0 divided by 2, which is minus sine 2x divided by 2. So this is just minus sine x. So it means if f of x is equals to cos x, then dy dx is equals to minus sine x. Thank you.